Hello, Dave Kenworthy here, continuing on from yesterday's video and now looking at the work of Jim Wakefield. Jim suggesting that if we set up a meter, we can derive from it a lunar year. Well, because the lunar year has got 350 odd days in it, we have to take 10 meters in this model, and we find that 9/10 of the 10 meter length produces a lunar year, and divide by 12 we get a lunation. And we also know the relationship between the meter and the cubit is 1.9008, but because we've got 10 meters in this column we need to take 19.008 there. And interestingly, 5280 times 3.6 is 19008. So the whole thing is revolving around the the imperial system, even though we can't see it. So we're going to start putting these values in now, and Jim's telling us we can find this lunar year. And when we look at the French meter, it's producing this value here of 349.9555 recurring. And I've been saying that the French meter isn't quite giving us the values that we're looking for. So let's put in this meter here, 39.375. And there we have it, 350 exactly, the lunar year. 354.375, the lunar year against the meter. The lunation period is 29.53125, exactly what Jim says it will be. And the solar year is looking 36458.333. And that is 20.8333 units away from 366.666, which is the next value that will get produced. And we'll get 352 in there. So we've got to put 396 in there. And there's all the values that we're expecting. And look at that, that's 3 times 99, 297. That's the value that Jim talks about. That's the meter that Jim talks about in his paper, Roll Rights to Stonehenge. I've got a copy of the paper, we'll have a look at it in a minute. So that's a key unit. And then finally we'll put this third Berryman meter in. And we get 364.5 for the solar year. These are the values of the Giza base. We just need to multiply each one of these by 100 inches to produce the descending scale of the Giza pyramid. And it's designed against 44/7, or 1760 divided by 280. And metrologists know that. I mean, it's standard metrology. And here we've got this ascending scale of the lunar year. So we've got two different lunar values here. And obviously we can work these together to find out what the difference is between the two, and work out the unit that's needed to transfer that to that. But these values are what they knew and what they were working with. And within this is contained the solar year at Giza and the lunation values that Jim Wakefield has talked about. And just to cap it off, Jim's dealing with the variable Sumerian foot, and he starts with 13.2 in his paper, All Rights to Stonehenge, calls it the Saxon foot. He also talks about 13.125 and 13.122, and he's also able to produce these numbers as units of area as well as units of length. So there's a lot more to this system than we're aware of. And these are Berryman's 3 digits that he used in his book, Historical Metrology. So this is all Berryman inspired work. And Jim's found all these numbers completely independently of Berryman. But when I bought Berryman's book and I found out that his Egyptian royal cubit was 20.625, I honestly nearly fell off my chair. And I've been studying Berryman vigorously ever since. Let's just finally look at Jim's paper. And this is his Saxon system, and we can see that these units are all in Berryman's book, and they go right back to the Sumerians. 13.2 inches. Cubit, 19.8, that's a Sumerian cubit. 2 Sumerian cubits are a Saxon yard, 39.6 inches. A royal cubit equals 20.625, exactly per Berryman. Jim's got 50 digits in this Saxon yard. Berryman's got 54, not a problem, it can all be adjusted. But this is a great piece of work by Jim. He's looking at the acre, and he's producing his analysis in acres at the Giza pyramid, as I am doing as well, because I'm following his lead and doing calculations in a slightly different way, but producing the same results. So, Jim's gone through writing this paper a long time ago, and he presented it to the European Association of Archaeologists, his paper, and after his presentation they accepted his paper, which obviously is a tremendous achievement, and one of the reasons why when Jim posts anything, we're all queuing up to look at what he's saying. So thanks for that, Jim, and hopefully people will begin to realise just how complex these systems are. So thank you for that. Bye.